This is video 19D for the Year 9 Mathematics course. In this video, we're going to be covering some example questions from Solution by Elimination, under the topic of simultaneous equations. The 8 questions we will be going through are now displayed on the screen, so I recommend that you attempt these questions before watching the rest of this video. Question 1. Solve simultaneously by method of elimination. 3x plus 2y equals 8. 3x take 4y equals negative 6. Okay, so the two equations that we have here are the following. 3x plus 2y is equal to 8, and 3x take 4y is equal to negative 6. First things first, I'm going to call this first equation equation 1, and this second equation equation 2. Now, what we should notice about these two equations is that the coefficients for the x's both match up and they're the same sign. We've got positive 3 and we've got positive 3, which means that we can now simply perform equation 1 minus equation 2. So what happens when we do this? On the left-hand side, we've got all of this stuff here, so 3x plus 2y. Then we will subtract the left-hand side of equation 2. 3x take 4y equals the first equation right-hand side, which is 8, take the second equation right-hand side, which is negative 6. Now let's simplify. The left-hand side, we've got 3x plus 2y minus 3x plus 4y. Then on the right-hand side, 8 take negative 6 is equal to positive 14. Then on the left-hand side, 3x minus 3x are going to cancel each other out. And so then we have 2y plus 4y, which is 6y. So we have 6y is equal to 14, or in other words, y is equal to 14 over 6, which simplifies down to 7 over 3. Now, in order to acquire the corresponding x solution for these equations, we're going to substitute y equals 7 over 3 into either of the two original equations. Just to make things easier, let's substitute this into equation 1. So by making this substitution, we have 3x plus 2 lots of 7 over 3 is equal to 8. 3x plus 14 over 3 is equal to 8. 3x is equal to 10 over 3, which therefore means that x is equal to 10 over 9. And so therefore the solution to these simultaneous equations is x is equal to 10 over 9 and y is equal to 7 over 3. Question 2. Solve simultaneously by method of elimination. 5x minus y equals 10. Negative 5x plus 3y equals 4. Okay, so the two equations that we have to work with are the following. 5x minus y is equal to 10, and negative 5x plus 3y is equal to 4. First thing I'm going to do here is classify this equation as equation 1, and then this equation as equation 2. Now, the first thing that we should notice about these two equations is that the coefficient for x in the first equation is positive 5, and then the coefficient for x in the second equation is negative 5. And so therefore, because these coefficients are negative versions of one another, we're now going to perform the operation of equation 1 plus equation 2. So, first things first, we have the left-hand side of equation 1, which is 5x minus y, plus the left-hand side of equation 2, which is negative 5x plus 3y, equals the right-hand side of the first equation, which is 10, plus the right-hand side of the second equation, which is 4. Now let's simplify these a little bit. On the left-hand side, we've got 5x and negative 5x, which are going to cancel. Then we've got negative y plus 3y, which simplifies to 2y. So we have 2y is equal to 10 plus 4, which is 14, or in other words, y is equal to 7. Now, in order to find the corresponding x solution for these equations, we can substitute this value of y into either of the two original equations. Just to make our life a little bit easier, let's substitute this into equation 1. And in doing so, we then get 5x take 7 is equal to 10. 5x is equal to 17, or in other words, x is equal to 17 over 5. And so therefore, the overall solution to these simultaneous equations is x is equal to 17 over 5 and y is equal to 7. Question 3. Solve simultaneously by method of elimination. X plus 4y equals 7. 2x plus 4y equals 10. Alright, so the two equations that we're working with here are x plus 4y is equal to 7 and 2x plus 4y is equal to 10. First thing I'm going to do here is classify this equation as equation 1 and then this equation as equation 2. Now, what we should notice here is that the coefficients for y in both equations match up. They're both positive 4, which means that what we're going to do from here is we're going to get equation 1 and we are going to subtract equation 2. So, the left-hand side of equation 1 is x plus 4y. Then we're going to subtract the left-hand side of equation 2, which is 2x plus 4y. This here is equal to the right-hand side of equation 1, which is 7, minus the right-hand side of equation 2, which is 10. On the left-hand side, let's just tidy this up a little bit. We have x plus 4y minus 2x minus 4y, and this is all going to be equal to negative 3. The 4y and the negative 4y are going to cancel each other out, and then we have x minus 2x, which is equivalent to negative x. So we end up with negative x is equal to negative 3, or in other words, x is equal to 3. Now, in order to find the corresponding y solution for these equations, we're going to have to substitute x equals 3 into either of the two original equations. Just to make our life a little bit easier, let's substitute it into equation 1. And in doing so, we end up with 3 plus 4y is equal to 7. 4y is equal to 4, which therefore means that y is equal to 1. So therefore, the solution to these simultaneous equations is x is equal to 3 and y is equal to 1. Question 4. Solve simultaneously by method of elimination. 6x take 2y is equal to 12. Negative 6x plus 5y is equal to 15. Alright, so the two equations that we have here are 6x minus 2y is equal to 12, and then minus 6x plus 5y is equal to 15. First thing I'm going to do here is classify this equation as equation 1 and then this equation as equation 2. Now, what we should notice here as well is that in equation 1, the coefficient for x is positive 6. In the second equation, it's negative 6. So we've got matching coefficients, but they are opposite signs, which therefore means that we are going to perform the operation of equation 1 plus equation 2. So, the left-hand side of equation 1 is 6x minus 2y, and we're going to add the left-hand side of equation 2, which is negative 6x plus 5y. And this is all going to be equal to the right-hand side of equation 1, which is 12, plus the right-hand side of equation 2, which is 15. Now, let's just tidy this up a little bit. 6x and negative 6x are going to cancel each other out, and then negative 2y and 5y is equivalent to 3y. And this is equal to 12 plus 5, which is 27, which therefore means that y is equal to 9. Now, in order to find out the corresponding x solution, we need to substitute y is equal to 9 into either two of the original equations. Just to make our lives a little bit easier, let's substitute it into equation 1. And in doing so, we then end up with 6x minus 2 multiplied by 9 is equal to 12. 6x take 18 is equal to 12. 6x is equal to 30, which therefore means that x is equal to 5. And so therefore, the overall solution to these simultaneous equations is x is equal to 5 and y is equal to 9. Question 5. Solve simultaneously by method of elimination. 4x plus 5y is equal to 20. 2x take 4y is equal to 1. Alright, so the two equations that we're working with here are 4x plus 5y is equal to 20, and 2x minus 4y is equal to 1. First thing I'm going to do here is define this equation as equation 1, and then this equation as equation 2. Now, what we should notice here is that neither of the pairs of coefficients for x or y match up. We've got 4 and 2 for the x's, and 5 and negative 4 for the y's. So what we first of all need to do here is we are going to manipulate these equations to have some matching coefficients. Just for simplicity, I'm going to choose the x's in this case. So currently the coefficients of x are 4 and 2. The lowest common multiple of 2 and 4 is 4. So we're going to leave equation 1 as it is, but with equation 2, we're going to turn this 2 into a 4. How we're going to do that? We need to multiply through the entire equation by 2. So we're going to define a third equation, equation 3, which is equation 2 multiplied by 2. And in doing so, we get 4x take 8y is equal to 2. And this here is equation 3. And so now, if we consider equation 3 and equation 1, we've got matching coefficients for x. We've got 4 and 4. And so therefore, what we're going to do now is we are going to perform equation 1 minus equation 3. Now, the left-hand side of equation 1 is 4x plus 5y. Then we are going to subtract the left-hand side of equation 2, which is 4x minus 8y. This is equal to the right-hand side of equation 1 minus the right-hand side of equation 3. Now, let's just tidy up the left-hand side. We've got 4x plus 5y minus 4x plus 8y is equal to 20 take 2, which is 18. On the left-hand side, the 4x and the negative 4x will cancel, and so then we have 5y plus 8y, which is 13y. So we have 13y is equal to 18, or in other words, y is equal to 18 over 13. Now, in order to find the corresponding x solution, we're going to substitute this value of y into any of the original equations that we were working with. Just to make our lives a little bit easier, let's substitute it into equation 2. And in doing so, we have 2x minus 4 lots of 18 over 13 is equal to 1. So we have 2x take 72 over 13 is equal to 1. 2x is equal to 85 over 13, which therefore means that x is equal to 85 over 26. And so therefore the solution to these simultaneous equations are x is equal to 85 over 26, and y is equal to 18 over 13. Question 6. Solve simultaneously by method of elimination. X minus 2y is equal to negative 3, and 4x plus y is equal to 9. Alright, so the two equations that we're working with here are x minus 2y is equal to negative 3, and then 4x plus y is equal to 9. I'm going to classify this equation as equation 1, and then this equation as equation 2. Now, first thing that we should notice here is that neither pair of coefficients for these two equations match up. For the x's, we've got 1 and 4. For the y's, we've got negative 2 and 1. So we're going to manipulate these equations to get some compatible coefficients. Now, just to make our lives a little bit easier, I'm going to manipulate the y coefficients. So, the y coefficient for equation 1 is negative 2, and for equation 2, it is positive 1. So what I'm going to do here is I'm going to multiply equation 2 by 2. Or in other words, I'm going to define a third equation, equation 3, which is going to be equation 2 multiplied by 2. So what this is then going to look like is 8x plus 2y is equal to 18. And this here is equation 3. Now the reason why I've done this is because now if we have a look at equation 1 and equation 3, we notice that the coefficients for y are negative versions of one another. we've got -2, and we've got +2. Which therefore means that we can now perform the operation of equation 1 plus equation 3. So, the left-hand side of equation 1 is x minus 2y. And then the left-hand side of equation 3 is 8x plus 2y. And this will be equal to the right-hand side of equation 1, which is -3, plus the right-hand side of equation 3, which is 18. Now, let's tidy up the left-hand side. The -2y and the +2y will cancel, and then we have x plus 8x, which is 9x, which is equal to -3 plus 18, which is 15. X is equal to 15 over 9, or in other words, x is equal to 5 over 3. Now, in order to find out the corresponding y solution, we're going to substitute x equals 5 over 3 into any of the original equations. Just to make our life a little bit easier, I'm going to substitute it into equation 2. And in doing so, we get 4 multiplied by 5 over 3 plus y is equal to 9. 20 over 3 plus y is equal to 9. Which therefore means that y is equal to 7 over 3. And so therefore, the overall solution to these simultaneous equations is x is equal to 5 over 3, and y is equal to 7 over 3. Question 7. Solve simultaneously by method of elimination. 7x plus 3y equals 18. 2x take 5y equals -4. Alright, so the equations here are 7x plus 3y is equal to 18, and 2x take 5y is equal to -4. First things first, I'm going to classify this equation as equation 1, and this equation as equation 2. Now, what we should notice here is that each pair of coefficients for x and y do not match up. For the x's, we've got 7 and 2. For the y's, we've got 3 and -5. Which immediately tells us that we're going to need to manipulate these equations to get some compatible coefficients. Now, you can choose either the x's or the y's to make compatible. In this case, I'm just going to choose the x's. So with the x's, we've got 7 and 2. The lowest common multiple of 7 and 2 is 14. So in order to make the coefficient of the first equation equal to 14, I'm going to multiply it by 2. Then for the second equation, I'm going to multiply it by 7. So we're now going to define two new equations. We're going to define equation 3 as being equation 1 multiplied by 2, and equation 4 as equation 2 multiplied by 7. And in doing so, equation 3 is going to be 14x plus 6y is equal to 36. And then equation 4 is going to be 14x take 35y is equal to -28. And so now what we notice is that in equation 3, the coefficient for x is 14, similarly in equation 4. So what we can do now is equation 3 minus equation 4. So we have the left-hand side of equation 3, which is 14x plus 6y, minus the left-hand side of equation 4, which is 14x take 35y, and this is equal to the right-hand side of equation 3, which is 36, take the right-hand side of equation 4, which is -28. Let's just quickly tidy up the left-hand side. So we have 14x plus 6y take 14x plus 35y is equal to 36 take -28, which is equal to 64. So now on the left-hand side, the 14x and the -14x are going to cancel each other out. And then we have 6y plus 35y, which is equal to 41y, and this is equal to 64. And so therefore, y is equal to 64 over 41. Now, in order to find out the corresponding x solution, we're going to have to substitute this value of y into any of the original equations. Just to make our life a little bit easier, let's substitute it into equation 2. And in doing so, we then end up with 2x take 5 lots of 64 over 41 is equal to negative 4. 2x take 320 over 41 is equal to negative 4. 2x is equal to 156 over 41, which therefore means that x is equal to 78 over 41. And so therefore, the overall solution to these simultaneous equations is x is equal to 78 over 41 and y is equal to 64 over 41. Question 8. Solve simultaneously by method of elimination. 6x take y is equal to 10, negative 3x plus 3y is equal to negative 5. Okay, so the two equations that we're working with here are 6x take y is equal to 10, and negative 3x plus 3y is equal to negative 5. I'm going to classify this equation here as equation 1, and then this equation as equation 2. Now, first thing that we should notice here is that neither pair of coefficients are compatible. We've got 6 and negative 3 for the x's, and we've got negative 1 and positive 3 for the y's. What this here tells us is that we're going to need to manipulate these equations to get some compatible coefficients. So, I'm just going to choose the x's in this case, in which we've got 6 and negative 3. So I'm going to multiply equation 2 by 2. So I'm going to define equation 3 as being equation 2 multiplied by 2. And in doing so, this equation can then be defined as negative 6x plus 6y is equal to negative 10. And the reason why we've done this is because now if we consider equation 1 and equation 3, we notice that for the x's, we've got coefficients of 6 and negative 6, and we can work with these. Because what we're going to do now is we're going to perform the operation of equation 1 plus equation 3. So, the left-hand side of equation 1 is 6x minus y. And then we're going to add the left-hand side of equation 3, which is negative 6x plus 6y. And this is equal to the right-hand side of equation 1, which is 10, plus negative 10. Now, let's just tidy up the left-hand side. We've got 6x and negative 6x, which are going to cancel each other out. Then we've got negative y and 6y, which are going to combine into 5y. Then on the right-hand side, we've got 10 plus negative 10, which is equal to 0. And so therefore, y is equal to 0. Now, in order to find the corresponding x solution, we're going to substitute y equals 0 into any of the original equations. Just to make our lives a little bit easier, I'm going to substitute it into equation 1. And in doing so, we get 6x take 0 is equal to 10, 6x is equal to 10, x is equal to 10 over 6, or in other words, 5 over 3. And so therefore, the overall solution to these simultaneous equations are x is equal to 5 over 3, and y is equal to 0.